Hi, in this week's webinar, I will try to introduce you to another approach, or let's say solution of the Go chase problem, but not presented as a walkthrough or as a solution to try and implement it in your own project, which I hope you have already finished, but as a way to enhance your understanding about ROS and different libraries, and in particular the OpenCV library, which is an extremely powerful open source library about computer visualization. And here is the website on the OpenCV library, which is, as I said before, an open source computer vision library. It has interfaces on both C++, Python. It has a Java interface. You can use it on Windows, Linux, Mac OS, Android. It's multi-threaded. It's extremely powerful, and it has tons of features that more than you can ask and imagine. And we will be using this library in order to tackle a part of the Go chase problem. Actually, I will make it more complicated than the problem or project you were given, just to give you an insight of how powerful this OpenCV library is. So let's go back to the laptop, and I'm going to first open a terminal. So let's start by creating the package by using the tacke create package, and I will name the package find nearest ball, and it will use ROSPy as a dependency. It will use standard messages as a dependency, sensor messages, and CV bridge, and you will see in a moment what this is. And I just press. If now I go up and try to tacke make, so now I'm almost done, but I also want to support the OpenCV library. So I will open the gedit here, and I will add just under here, which says find. I want to add an external library, so I would say find package, and then OpenCV. Be careful with the capitalization, which is very important. And I will first try to say to required, which means I want to add the version 2 of the package. OpenCV is now in version 4, which has just been released, but let's try to add a package, the version 2. And now if I try to save that and go back and recompile, it will say, oh, no, I have found a CMake file, but the version that you have installed is version 3. So this is one way of finding which version you have installed. Another simple version is just try to hit Python and go into the REPL of Python, and then just try import CV, and then it will say that the current version is 3.3.1 dev, and it's the same one that's reported up there. So now I'm exiting the REPL. Everything is fine. I'm clearing the terminal. So I have just done the first step and have configured my package to use the OpenCV for Python, not for C++. I will use Python in this project just to make it easier to write and compile. Actually, I won't have to compile, so you will see everything debugged while we are building the project here. Now I'm going to into the source folder here, and I will create a new document. I will name it find ball, and it's a Python file. I will change the permissions to allow executing the file as a program. So I'm fine now here, and I will open it with Visual Studio Code. Let's add the first important line that will tell the system that it should use the Python interpreter to run that. So, and then import ROSPy, import. I will also use the NumPy only slightly as NP. And now I will just create some boilerplate. This tells if this module is executed as a main and not called by a library. Then rospy.init node with a name find ball node, and then rospy.log info. So some feedback so we know it is working, not created, and then write try rospy spin spin except keyboard interrupt print shutting down. And then CV2, and I will explain what I'm doing here. All windows. So one of the first things that I would try to do is try how to make ROS and CV2 work together. And if I try and search that, you will get this page from the original wiki, and it will tell you how exactly you are going to work with ROS and OpenCV. And here it says that you should first install the CV bridge. So this is why I'm importing the CV bridge, and I'm actually following this tutorial on how to make ROS communicate with OpenCV. Actually, the main thing CV bridge does is just takes the image and transforms it in a way that the CV can understand. So this is basically what it does. There's nothing fancy about it. So let's us start coding, and to make everything a little bit more tidy, I will wrap everything up inside a class. So let's create a class and name the class find ball, and def I will create an instance of bridge. So first of all, I have to import bridge because I haven't done so. So I will say from CV bridge, import CV bridge and CV bridge error. So first of all, so I am creating an instance of CV bridge and storing it because I'm going to use it again and again. The second thing I will do is I would create an image subscriber and rospy.subscriber, and then I have to add here a topic to subscribe. What type of topic, what type of image messages does this topic support, which would be image, and then the callback, which I will write just right below, and it's image callback. So first of all, let me import this image. So type, so I will say from sensors messages.message import image. So now I have imported the image. Now then the topic name. The topic name depends on how you have defined it. Here, if I go here to my robot and go to the URDF file and open the gazebo here file, you will see that the camera is under my robot camera 1 and the topic name is RGB image row. But there is also another way to find out. Now, before doing anything fancy, let me first comment this out so it will not cause any errors, and let me add here, just before initializing, let me create a find ball instance of the class and say find ball, and so I've created the find ball here just before initializing the node. Well, there's no need for that. I can do that after the node is created. There's no. The next thing I should do is just launch the robot that I have created for the GoChase project. So it's named my robot, and I'm just using the world launch. And as you see here, this is what we view, and this is the camera. Now the ball is outside the world here, and what I will do is select the ball and then I can select it from here and just press copy and then paste and create multiple instances inside and around the robot. So now let's see if RVs, and you see that RVs now, you can see the camera feed and you can see that there are 3 balls inside. So actually everything now is working. I'm getting the right feedback. So it's time for us to work. I'm going back to my editor and let's go here and clear the screen. Now I can do a ROS run and I can use the package I've created, find it in nearest ball, and I can use the name of the file, which is findball.py, and run it. And it says that I have an error. This is fine because you can see that I can just run with the gazebo running in the background, so it's faster to program. I don't have to close everything down and open again. So for prototyping is a much faster procedure. So this should be a dot here. I'm saving and I'm running again. And it says expect. Yes, of course, it's not expect, it's accept. So another typo, and I have to just change that to accept because this is the right keyword, and then running again. And now you see node created, so we know that everything is running. Now, if I open another terminal and say ROS topic list, I can see the list, the number of topics, and I can see that the name of the topic I'm interested here is my robot camera 1 RGB image row, and it's the same as we saw in the gazebo file before. So I'm now copying that. I'm going here and stopping the execution of that program, and now I'm uncommenting that and pasting the correct topic. So the first step is completed. Now I will have to actually create the image callback. So let me create some space here and write def, not here, this is a class function, and it will be named image dot callback and self dot comma image data. Now, okay, try CV image equals. Now what I want to do is transform, as I said before, the format of the image from the ROS format, the one that we get from the raw image feed, to the one that CV can understand and filter. So it's image, and autocomplete can help us. So it says image message to CV2. It's self-explanatory, and what I pass here is the image data, and then what type of encoding I want to transform it to, and I will use the default one, the default that CV2 uses, which is BGR, which is blue, green, red, and 8-bit numbers. So values are from 0 to 255. And also I'm going to use the resize function of CV2. Well, the reason, I have two reasons for that. The first is that I want to show you how to use the resize function, and the second one is that when we do not need a very big size for the image to work, and smaller sizes make processing the image much faster. So when you do not need large amount of images, just resize them and work on them. It's much faster to work, and you will save a lot of time. So I will use cv2.resize, and then resize gets first the image that you should resize and the size of the destination. So, and if you look at the documentation, it says that if you passed a 0,0 argument, so you do not actually pass any size, but you pass some fx and fy values, which are ratios on how bigger or smaller you want the image to be. So I will pass here 0.5 for fx and 0.5 for fy, and this that means that I want the image to be sized at half. So this is basically how to resize the image, and then I will say here except CV bridge error. So if this cannot be completed, it will throw me an error, and what I would do is just pass it to ROSPy and log the error. Log error E. So this is the first step. And now, before just starting to do more things, I want to visualize what I'm doing, because I cannot do that blindly. And we are very lucky that OpenCV has some tools for that. And now I will write a function that we will use again and again now, and I will call it imagecv.show, not so. And what this image will do will take the image data and it would output that in a window. So we will use the image show function, and we need a title for the window, image window, and also we need the data that we should pass the image data, and this is pretty much. And we also need to tell CV to wait a few milliseconds in order to allow everything to be drawn. And so I will say just wait key 3, so it waits 3 milliseconds and then just draws the frame. Let's see now if that works, and to do that we have to call the function. And so this is simple. I will say here self dot image CV show and pass the CV image. Now let's see if this works. I'm just trying to run again. And you see we have a window and we see the 3 balls, and the 3 balls are exactly the same as the ones we get here from the feed. So if we change anything, as we will do a little bit later, we'll see everything changing here. Now let's go back. So now the next step is I want to isolate the balls, the white balls. So I will create an image, I will create a function, and I will call it image create mask. And what this function will do is it will take some image data and it will take a lower, let me just wrap it down below to make it prettier, and it will take now a lower range of data, of values, and an upper range of values, and check if the pixels, and isolate and mask all the pixels that are between this range. So these are RGB values, BRG values to be exact, and I want them to be white, almost white. So I could make this even higher and just require absolute white pixels, but you can see that with this way we can isolate various colors and we can make it even more complicated, but I wanted to keep it simple. So this is the function, and now just return CV2 in range image data, lower range, upper range. So this will actually create a mask, and all the pixels that are within the arrays we have provided will be white, and everything else will be black. So now let's use that and see if this is working, and I will do that here and say mask equals self dot create image create mask, and I will get the image from above, and I will not pass lower and upper range, and if I don't pass it will use the default. So this is basically what I should do, and now I want the image not to show the original image but the mask to see if everything is working. So I will pass to the image CV show function the mask. Now let's go back. It has not exited, so let's clear that, and now run again. And you see now everything is black and the three balls here are white. So we have done a step. That's fine. So what's next? We want now to find the contours of the three balls that we see there. So luckily for us, the OpenCV library has a function for that, and we will use that function. Let's say find contours, and what this function will need is just the mask we have created before. So we will pass the mask and it will find the contours. Now if you go and see the documentation, which I will provide in a separate file, all the required links, I will use the find contours and this requires the image we want to find the contours. Now it needs two variables. The first one, it says if we want to create a hierarchy of if one object is within another object. We may want or we may not. This is not relevant here. I will ask the algorithm to return the hierarchy, but it's not relevant here. And the next parameter is what algorithm we should use to find the contours. I will use here the simple approach because it creates much less points, and we are not here to find a very exact contour of the shapes, and we have a very simple shapes too. So the value is chain approximate simple, and this function returns three things. It returns the image, a list of contours, and the hierarchy. So we will look each one of these in order to understand what they do, but we will not go in details and not use the hierarchy because it's not needed here, but it's nice to know what it does. So I will tell here rospy.loginfo detected contours. Since contours is a list, we are going to use the length of the contours to know how many contours we have found. And also, since I want you to understand how everything is structured, I will also paste some. I will also export some information here and say first contour has points. So just to output how many points the first contour has. And I will say here len of contours. So the first contour is contour 0, and I will output how many points it has. And I also want to print the hierarchy in order to explain it. I will go into this function a little bit more later, but let me first call it here and just to show you what is going on. So I will say self.find contours and I will pass it the mask. Now I'm going here and running everything. And if I don't have any errors, no, I have, yes, spelling errors. The contours is very easily mistaken. So contours is this, and this, and this. So now everything should be spelled correctly. So let me exit the program and explain what is going on. So as we expected, it says it found 3 contours because we see 3 separate balls, and it says the first contour has 46 points. So it doesn't actually recognize it as a circle, so it just finds some points and in order to describe this this image. And this here below is the hierarchy, and this is the first one is for the first contour, for contour number 0. The second one is for contour number 1, and then the last one is for the second contour. So now, what does that one means? It means that the next contour is number 1. So yes, this is contour number 0 and the next one is number 1. This -1 says that the previous contour is -1. So there is no previous contour. And this is right, since this is the first. Now if we go to the second contour, is contour number 1, and it says the next one is number 2 and the previous one is number 0, which is correct. Number 0 is the previous, number 2 is the next one. And if you go to the last one, it says the next one, there is no next contour, and the previous one is number 1. And here it says it allows us to know if any circle is inside any other one. Since these are all -1, it means that we do not have nested objects. But if we had nested objects, those values would not be -1, but we will not actually need this information right now. So let's go back to our code and try to improve it. First of all, I don't need these debugging sentences. Well, maybe I can just live with that one that says how many contours we did find. And now I will do the following. I will do for contour in contours. So I will go through every contours, and now I will use a function of CV, which is contour area, and I will pass the contour. So what I'm actually doing here, I'm trying to find out the area of each contour. So I have 3 circles or circular objects, and I want to know how much space does each one has. So I do this, and I store that in a variable that I call it contour areas. And the next thing I want to know is to find which one is larger. So contour areas dot index max of contour areas. So now I know the index of the biggest the index of the circle that seems larger to me. But since all balls are the same size, actually size is if the ball is closer or more far away from me. And for now I am interested in the ball that is closer to me. So I'm trying to find the nearest ball and go and probably collect it. This is the target I have in mind. So with this algorithm, I just identify which one of the balls is nearest to me. And I am returning, and now here I haven't returned yet, but I will return here from the contours. I will return the one with the max index. So back here I will say ball contour. Now this means I asked this function, I provided it with the mask, and it returns me the contour of the ball that is closer to me. So now I've made progress. So now what I want to do, I want to find out exactly where in the image does this ball exist. And for this, guess what? I will create another function. I will name this function center of contour. So def center of contour, and the only argument I need to pass here is the contour. Okay. This requires some mathematics and some extra knowledge, and actually the centroid of an image is acquired by the moments of the contour, and you can find more in wiki about centroids and how you calculate the centroids of an image. So pretty much is the following. I'm calculating the moments of the contour, and the centroid the Sx is the following. I'm pasting just in order to be faster. So as you understand, M would be just a dictionary. So I am creating the Sx and Scy coordinates, and will return as a list. So I'm pretty much done. I know the contour I'm looking for, and then I know the center of the circle or the centroid of the object I'm asking. So now I want to also visualize that. For that, I should change the image show function in order to show more details. So let's say we pass it a contour, but it can be an empty contour if we don't pass anything. And we also pass the centroid, which could be an empty list if we did not pass anything. So here we will say if contour not equals to an empty list and centroid not equal to an empty list. So we have information about those two variables. We are going to use the draw contours function of CV2. Contours. No, the spelling is again wrong. So draw contours. And this function actually draws on the image we provided. So we will provide with an image, and the image we have already the variable, which is image data. And now let's explain the variables one by one. First of all, it needs a list of contours. And since the contour I get is a single contour, I have to wrap it inside the brackets in order to be a list, and it's a contour. Also, it needs the index of the contour to be drawn, and contour index. And if you pass it a negative number, -1, it will draw all the contours that are in the list. Next, you need the color. And remember that this is a BGR, so blue, green, red. So I'm telling this to be a green color. And also, you pass the thickness of the line that needs to be drawn. So this is much the draw contours function. I will also like to output some information on the picture. First, I will need to calculate some variables. I want to know how much of the center of the image is the ball. So since our robot has or probably has the image sensor in the center, and so going forward means going in the middle of the image. I want to know how many pixels to the left or to the right is the center of the centroid we are looking at. So the first thing I will do here is of center variable, which is, I will make it a string, and so I will get the centroid first value, which is the x position, and I will subtract it by the image data dot shape 0 divided by 2. So the image shape 0 it's the width of the page of the image. So I want so this difference is how much to the left or to the right is that point. A negative number means if we say is minus 20, it means that it's 20 pixels to the center of the image. If it's plus 30, it means it's 30 pixels to the right. And also, I would also like to, this is of center X, and also I would like to find now I want to also find how many pixels from the bottom of the screen is the centroid, because when the object is very close to the bottom of the screen, it means that this object is very close to me. So it might mean that I have to slow down because I'm approaching that that object, or I should take an action about that object. So it's very important for me to understand how close I am to the object I'm seeing. And the quantity I have to put here is simply the image data dot shape 1, which is the height of the image, and from that I will just subtract the centroid y, and then I'm just assembling a text which I just paste it here because I don't want to write everything down. So now I want to insert this text that I have generated on the image, and to do that I have to use another CV2 function, which is CV2 dot put text, and the image I'm painting on, which is image, no, it's image data, and then the text I should write, which is the one I have assembled in off center. Now it tells me I have to supply where I want to put that text, and it needs a tuple, a y and an x coordinate, and I will say that I want a centroid 0, which is the x position, minus 20, a little bit to the left, and then centroid 1 minus 20, and then I have to supply the font face, which is CV2 dot font. Now I need to paste that because I will definitely make an error on the font face. And then the font scale, which here I would say it's 0.5. You can experiment with that. And the color, which in my case I choose to be black, so everything is 0. And pretty much everything else is the same. And in order for that to be applied, I will have to go back up here and here I have to change Now I have to get the image back. No, the image back, and also have to provide now the contour which is expecting, ball contour, and also the centroid. Well, the centroid, yes, but here I haven't yet calculated the centroid, so let me do that. I'll use the function we have just calculated before, and it will say center of contour, and just pass the contour. Oh, this is misspelled, contour, and just make everything okay. So everything seems correct here, but in order to be sure about that, we have to go back here, clear our terminal, and run again. And it says, okay, another spelling of the contours, which is on line 40. Let me see where this error is. Line 40, contours. I think here is the error. Let me run again to see if now it works. Again, another center takes exactly one argument, 2 given. Okay. Yes, I forgot here that I need the self because this is inside the class. Global contour is not defined, and this is on line 29. Yes, because I have to. Oh, no, it is better to name that contour. We don't have to use the same ball contour. Contour is fine. And then let's see if this runs now. Yes, another error. So here is contour, and it should be here as contour. So another typo. And now it seems to be working, and let's open terminal. Oh, and we see that actually it is working, and it says that it is 94 pixels to the left and 107 pixels from the bottom. And this is the correct one. Now let's see if it indeed works. I will open Gazebo now and open that and just try to say it's always on top. Now let's pick that one, and okay, let's bring it closer in order to make it easier to work with, and pick along that axis and bring it here closer. And now you see it's updated and it says this is closer, and if I get that one, it's working fine. So the basic algorithm is working fine. How can we prove that? So the first thing we can do is turn that into a service. So it could be a general service that will send an image, and it will just respond with that point. So The image is the input, and the output is just two numbers, 146, 84, which is how left and from the top the centroid of the target is. And based on that, the robot will just adjust its movement. It will adjust its speed, and it will adjust its angular speed and everything. And the good thing about that is that it can be used by many robots. So imagine you have 10 robots, and each robot has its own camera, so you don't have to write the code 10 times. You will have a service, it will receive that image, and it will respond with the correct point. So every robot will be able to use that service.